All right, so hello and welcome to the walkthrough series. We continue looking at different implementations for the 9618 variant 4.1 in this case. And we'll be doing the Python implementation for question 1 in this video. So without further ado, let's actually just go ahead and jump in and look what we have going on in here. Okay, so here we are given a file called hashtable data.txt, but of course we're not going to be using this one for question 1, because you can see here right here that it says we're going to be using this for question 3, so we don't need the file as it were for question 1. So let's see what we have going on here. So it says here that a program stores integers in a stack. The stack is represented as a 1D array of 30 elements with the identifier stack. The global pointer, top of stack, stores the index of the last element inserted into the stack. Top of stack is initialized to -1. So we are being given a little bit of background information there. Then on part A, here we are required to write program code to declare stack, initialize each element in the array with a null value, and declare and initialize top of stack. And of course, we are supposed to save our program as question 1 underscore n25. Then we'll be copying the code and pasting it inside of the evidence document. So let's go ahead and look at the declaration of stack and top of stack right here on my implementation. So we are looking at line number 4 there. That's where I have my solution to question 1a. And what we're doing there is you see that we have a variable called stack right there, and we are initializing it to a list that's going to have 30 elements of type none, is it? Because you realize that here we were told that where is it? Initialize each element in the array with a null value right there. So that's what we are doing there on line number 5. We have a list called stack, and that is going to hold 30 elements of type none. You can see we are multiplying that by 30, so that's the Pythonic way of initializing a list of n size. So here in our case n is 30, so we have a list that's going to have 30 elements, but currently it has been initialized to none. Then it says here that we should also have the variable, which is a global pointer rather, called top of stack, and it has an initialized value of -1. So that's what we have going on there on line number 6, right? So with that being said, you would have finished your solution to this part of the question, and of course you would go ahead and copy the code and paste it inside of the evidence document. Moving on to part B, we have a function called push that's going to take an integer parameter. If the stack is full, the function returns false. If the stack is not full, the parameter is inserted into the stack. Then the pointer is updated and the function returns true. So essentially, if you remember your stack operations, you realize that one of the operations that we perform on stacks is to push, which is essentially pushing a value, putting a value onto the stack data structure, as it were. So we are to implement code for this, right? So let's go ahead and look at the implementation that I have going on here, starting on lines 8 to line 16. Actually, line 9 to line 16. Line 8 is just a comment there. So we perform a function definition. We give it an identifier called push. Then it's going to take a value, which is going to be an integer. But then again, you remember that in Python, we don't really have to concern ourselves with type declarations. Right? We just write the variable name there. But of course, we could actually use, you might actually see that I tend to use type definitions in some of the implementations that I've done. But it's not really necessary. Sometimes I do it, sometimes I don't, because it's optional really. Then on line number 10, what we're doing is after the function head on line number 9, you see that on line number 10 we begin the function body, and we are using the keyword global there because we want to refer to the top of stack variable that we declared on line number 6 right there, is it? So this global keyword, it's actually telling the Python interpreter that this top of stack variable, we are actually referring to a variable that is outside of this particular function. So it's going to look into this particular Python script. It's going to take this top of stack value that we've going on line number 6. So that's what the global keyword means there. Then we are checking to see if the length of the stack is equal to the length. Sorry, we are checking to see if the top of the stack is equal to the length of the stack -1. This is because you have to remember that array elements, they are zero index based, is it? So let's say if the stake is 10, then it means that the 10th most element is an index position of 9. So that's why we have to subtract by 1 there on line number 11. Then if they are the same, then it means that our stake is full, so we are going to return false, meaning to say that we cannot push anything onto the stake. Otherwise, on line number 13, we are looking at an alternative situation whereby we have space to push the element as it were. So the first thing that we need to do is to update the top of stake pointer so that it points to the next element that is free. Then on line number 15, we are now taking the top of stake, the current top of stake value, and use it as an index to point to the stake list as it were. And essentially, we are taking that value and putting it at that current position that is being pointed at by top of stake inside of the stake list. Then we return true to signify that we were able to push our value onto the stake. So then, of course, you'd go ahead and copy this and paste it inside of the evidence document. All right, on line numbers, actually moving on to the next part, part C, we have a function called pop that's going to return the next integer in the stake, and it's going to update the pointer as necessary. If there's no data in the stake, the function returns the value -99. So we have to write program code for pop. Again, this is another function, this is another stake implementation or operation rather that you should know, that we can push, we can pop, we can also pick, but of course for this question we don't have pick, so we are just going to be doing push and pop. So again, on line 20, line 19, we have a function definition, but remember we don't have to put a parameter because it says that it just returns. So the function pop doesn't take a parameter, so that's why you see that here we don't have a parameter definition on line number 19, so it's just a void function as it were. Then on line 20, we are again referring to the top of stake global variable there. Then on line 21, we are checking to see if the top of stake is currently equal to -1, in which case it means that the stake is empty, so we cannot pop anything. And according to the requirement right there, it said that if there is no data in the stake, the function returns the value -999, and that's what we are doing on line number 22 there. Otherwise, on line number 23, we are looking at a situation whereby we have data in the stake. So we take the value that is currently being pointed at by the top of stake variable inside of the stake list. Then we store it inside of that value variable. Then on line 25, since we've removed that particular variable, we are now initializing, or we are now reassigning that as an empty space, is it? So that's what we're doing on line 25. We are just assigning a now variable to where we removed that value right there on line 24. Then on line 26, we have to decrement the top of stake pointer because remember we've just removed an element from the list as it were, so it means now we are less by 1. So that's what we're doing there on line 26. We have to decrement top of stake by 1. Then on line 27, we return the value that was at the position we indicated on line 24 there, is it? It's because you will see here that it says the variable pop returns the next integer in the stake, so that's what we're doing there on line number 27. So of course you would go ahead and copy this code and paste it inside of your evidence document. Alright, so coming now to the main program, our main program is supposed to generate 40 random integers between 0 and 1000 inclusive rather, and it's going to attempt to insert each one into the stake using the appropriate function, which is push. If the returned value from the function core indicates the stake is full, no more integers are generated and stake full is output. Write program code for the main program. Right, so I have my main program down here. So let me scroll all the way where it is on line 54 up to 69. But of course, there is going to be an implementation for part F, as we'll see later on. So to address part D, we are supposed to generate 40 random integers and try to push them onto the stake as it were. So let's see that in action. Again, we are referring to the global top of stake and stake variables, that is the pointer and the list respectively, on line 55 there. Then on line 57, we are basically resetting the stack for each run, is it? So we, again, you see this notation that we did it earlier on part A, right? Then on line 62, we have that we are using the range function. Basically, we're just using a for loop, as it were. So we want a range of 40 elements. So what we're going to do is we are going to have values generated randomly, right? And the way we're going to be going about that is to make use of the random library. You see that we imported it right there on line number 2. It's going to allow us to create a random, to make use of the random function, as it were. So let me just come down here. You see that we are using the random package, and we are taking the randint function, which is going to generate for us random integers between 0 and 1000 inclusive, is it, according to the specifications right there. Then if it didn't push, if it fails to push, basically that's what we are saying on line 64 there. If we fail to push that particular number, then we are going to print stack full. But otherwise, it means it's still going to push the value onto the stack, as it were. So that's that's the implementation for this part of the question. So of course, you'd go ahead and copy this code and paste it inside of the evidence document. Then moving on to part E, we have the procedure called find values, and essentially it's going to pop each integer from the stack until the stack is empty. It's also going to find and output the largest number that was in the stack in an appropriate message. It's also going to find and output the smallest number that was in the stack with an appropriate message. So we are to write an implementation for find values right there. So let's go ahead and look at that implementation that I have going on here on lines 30 to 51. Alright, so line 30, that's the function here that they find values. Then on line 31, we are referring to the global variable top of stack. Then if the top of the stack is currently pointing to -1, it means that the stack is empty. So we simply return or exit out of that particular condition there. Then on line 36, we are instantiating a temporary values list that we are going to use later on to look for the maximum and minimum numbers, as it were. So we then proceed to look at to initialize a loop, rather a while loop, right? Because why the reason why we are using while loop is because we don't know how many elements we have inside of our stack, as it were. So we are checking to see if the top of stack is not equal to -1, then we are going to pop a value there on line 41 by making use of the pop function that we created earlier on. So that the value that we are going to pop, remember pop returns a value, so we are going to hold it in this value variable right here. So it's important to realize that this value variable, it's local to this particular find values function. It's different from the one that we have in pop, right? They are not related because they are local variables respectively. So basically these values, they reside in different memory parts or different parts of memory, as it were. Then on line 42, we are checking to see if value is not equal to -99, in which case we are going to append that value to the temp values list that we declared on line 37 there. So we are going to repeat this until we no longer have anything inside of the stack. Essentially, we are going to repeat this until we pop every element that is inside of the stack. At which point the loop is going to terminate. Then it's going to pass control to line 45, whereby we check to see if the temp values is something. So if the temp values is something, we are going to run the code that is inside of here. So what we are doing on line 46, we are using the built-in max function that is built into Python. So essentially, it's just going to check the maximum or the largest value inside of a list of integers. And you remember that temp values, when we popped our integers from the stack, we are putting them in the temp values list, as it were. So it means that we are using that to check the highest or the biggest integer, as it were. Then we're also doing the same thing for the smallest integer, but of course we use the min function, as it were. Then we go on to print the largest number as well as the smallest number on lines 48 and 49. Then on line 50, we are just handling a situation whereby we don't have anything inside of the stack, so we output an appropriate message, no values found in stack. Yeah, so that will conclude the implementation for part it's part E or F. Yes, it's part E. Sorry, it's part E. Then of course you'd go ahead and copy the code and paste it inside of the evidence document as it were. Then moving on to part F. Can you make the question paper here? So we are to extend the main program to call find values. So let's go ahead and look at that implementation right there on line 69. So we are calling the find values variable there, the function, sorry. Then the last aspect of the question requires us to test our program, then take a screenshot of the output. So let me just come here, pull up my terminal, and make sure it's blank. Then we want to run this script. So I'll just cycle through the commands because I actually did test it out when I was doing the implementation earlier on before I started recording the video. So there's my command there. So you see that it's saying initially it says stack full, then it begins to output the largest number, and it's also going to output the smallest number, is it? So of course you'd go ahead and take a screenshot of your output and paste it inside of the evidence document. So yeah, that's just about it for this episode. I'll see you guys in the next one.